All right, so as far as test corrections go, this is test number 2 over equations and inequalities. I will just go ahead and jump in to number 1, where it says Frances wants to buy a leather jacket that costs $200 after adding tax. She has $50 in her savings account and earns $7 per hour babysitting. Which equation below would she use to determine how many hours, H, she must babysit before she can buy the jacket? So I'm going to start by underlining any key words that are going to help me write my equation and circling constants and boxing variables. So the cost is $200. That $200 isn't going to change. It's already been decided. She has $50 in her savings account. Again, a constant amount that she has. She is earning $7 per hour. So I know that that's a variable because of the per. And then she is trying to determine how many she needs to order before she can buy the jacket. So she needs that to be equal to $200. So we have $200 is the jacket equals $50 plus $7 per hour. So then finding the one that looks like this will end at B. Number 2, the table below shows the service rates for 2 computer repair companies, TechRite and Best Buy. So TechRite charges $75 for a service charge plus $50 an hour. So we have our constant. And over here we have a service charge, so that's a one-time fee, plus an hour, $70. So which equation could you solve to find the number of hours at which TechRite would be less expensive than Best Buy? So less expensive, so we know we're going to be looking at a less than sign. And so then we can write our 2 equations. So TechRite, we would have 75 plus 50x, and for Best Buy, we would have 25 plus 70x. And we want TechRite to be, I'm going to look at this. So if I have TechRite in purple, so when I'm looking at my answer choices, it looks like all of the TechRite is on the left. So we're looking for TechRite, and the other side is looking like Best Buy. So we need our TechRite to be less than, so TechRite has to be less than Best Buy. So right off the bat, we can eliminate this one because that one's greater, and this bottom one is greater. So now we're looking at answer choice B. We see that this right here is a negative sign, but in the question we have a plus. So that leaves us at C. All right, this one could be kind of tricky, but we're going to break it down. So I'm going to rewrite my equation down here and give you a chance to rewrite it on your paper. So 1/2 minus 5 over 8x equals 7 over 8x plus 7 over 2. So I'm going to start by circling and boxing. So I'm going to circle my constant numbers, and I'm going to box my variables. I draw a line at my equal sign to separate the 2 sides, box for a variable, and circle for a constant. So we have our 4 questions from class about variables and constants and so on. So our first one is talking about like terms. So in this case, we don't have any like terms on the left. We have a circle and we have a box, and over here we have a box and a circle. So we don't have to combine any like terms. So our second question that we're going to start at is, does the equation contain variables on both sides of the equal sign? And I'm going to make variables yellow. So we have a variable here and we have a variable here. So what we're going to do, since we have variables on both sides, is find our least variable, our least coefficient, and move it to the other side. So since a negative 5/8 is smaller than 7/8, we're going to move this to the other side, 5/8x. So on the left side, that will become a 0, and then we'll be left with 1/2 on the left equals 7/8 plus 5/8. So since they have the same denominator, we can add them. So 7 plus 5 is 12/8x plus 7/2. All right, so then we're to our third question, which is, does the equation contain constant numbers on both sides? So if I were to, I'm going to make my constants in purple. So we have these two constants and they're both on separate sides. So what we're going to do is to move the constant that's on the same side of the equal sign as the variable. So this 7/2 is on the same side of the equal sign as the x, so we're going to move it. So this will become 0, and then we will do our subtraction here. So again, we have the same denominator here, so you can subtract as normal, but it would have to be, I'll write it off to the side, so 1/2 minus 7/2. So 1 minus 7 is going to be a -6, and then our denominator stays the same. So again, this could be done on the calculator just as easy. Actually, let me show you. Let me pull up my calculator. So this is very similar to the calculator that we use in class. So I'm going to go ahead and put my fraction in. So it was 1/2 minus 7/2. Push enter, and that gives me a -3. And we see that we got that as here as well, because -6 divided by 2 is a -3, equals 12/8x. And then our last step is to ask ourselves, is there a coefficient other than 1 with the variable? So we have our coefficient. I'm going to highlight it in green. We have our coefficient here. So as we've worked with fractions, we have, rather than dividing by our coefficient, we've been multiplying by our reciprocal. So the reciprocal of 12/8, I'm going to put this dot here is going to be for multiplication. So our reciprocal is 8/12. And then to make sure to keep our equation balanced, we will multiply by 8/12. And I'm going to recognize here, so this 12/8 from the beginning, sorry, I should have mentioned this right here, the 12/8, this could have been simplified to 3/2. I just figured since we were going to be solving all the way down, I would just wait until the end. But if you got 3/2 when you put it in your calculator, you're not wrong. So, all right, so on the left side, on the right side, these two are going to become 1, and we'll be left with just an x. And then on the left side, we're going to take a -3, and multiply that by, forgot the numbers, 8/12. 8/12. Push enter, and that gives us our answer of x equals -2, which we see here as A. back to number 4. So 2 8th grade classes are selling raffle tickets to raise money. One class is selling tickets for $250 each and has already raised $350. The other class is selling tickets for $3 each and has already raised $225. Which equation can be used to find T, the number of tickets each class needs to sell, so that the total amount raised in this is the same for both classes? So I'm going to go back in, underline, circle, and box accordingly. So we have this each here, which tells us that this $250 is going to be a variable because it's going to change based on the number of tickets you'll buy. Already raised is going to tell us that this $350 is going to be a constant. It's a number that we already have. We have a starting amount. The other class is selling, so we have $3 each. Tells us that $3 is going to change. It's going to be our variable. And then already raised $225. Which equation can be used to find? So then we're looking for the classes to be the same. So we have one class that's going to be, I'm going to go back in and underline this and, which will tell us that we need to add. So 250x plus 350 equals $3 for the other class. So you could do 3.00 or just 3x plus 225. So then we're going to find the one that matches this, which is C. And just going to point out that we could have eliminated this B right off the bat because it had the variables switched and the constants. All right, number 5, which equation best represents the following situations? There are 2 limo companies that charge based on the number of people, X, that they carry. Limo A charges $30 plus $4 per person, and Limo B charges $70 plus $2 per person. So I'm going to go in, and we know we're looking at X as our variable. So we have Limo A charges $30, so there's an initial fee, a charge of $30 plus $4 per person. So we know that's our variable. And then the same charges $70 plus $2 per person. So I'm going to take Limo A, we have $30 plus $4 per person. They told us to use X right here in the question. And then company B, we have $70 plus $2 per person. And we're looking for when they are the same. So we notice even in our answer choices, they all have equal signs. So we're looking for the one that matches up exactly to ours right here, and that is B. All right, this one, Carnival M charges an entrance fee of $5.65 per ticket for the rides. Carnival P charges an entrance fee of $10.45 per ticket for the rides. How many tickets must be purchased in order for the total cost at Carnival M and Carnival P to be the same? So we have an entrance fee, which tells us of $5, which tells us that this $5 is going to be a constant. And then we have 65 cents, which is going to be a variable because it says per. And then we have an entrance fee of $10 and then 45 cents per ticket. So we're looking for, in the other ones we've had to just write the equation, and in this case our answer choices aren't equations, so that means they're asking us to solve how many tickets must be purchased for them to be the same. So I'm going to go ahead and write Carnival M, which was $5 plus 0.65 x. And then Carnival P is going to be $10 plus 45 cents per ticket. So then we're going to take this and we're going to solve it. So we're going to circle again. We already knew these were our constants and variables, but I just like to reiterate them as I solve. So we're going to, we see that there aren't like terms on the same side of the equal sign, so we're going to look for variables, and we have our variables that I'm going to highlight in yellow. Variables, we're going to look for our least coefficient, so 0.45 is less than, so I'm going to subtract that from both sides. On the right, that will become 0. And then on the left side, we'll be left with 5. And then 0.65 minus 0.45 will be a positive 0.2x. And on the right, we'll have 10. And now we have our constant numbers. So we have a constant here and a constant here. So what we're looking for is the constant on the same side of the equal sign, which is 5. So we're going to subtract 5 from both sides, and we'll be left with 0.2x equals 5. And our last step is to ask ourselves, is there a coefficient other than 1 with the variable? And our coefficient here is 0.2. So what we'll do is divide both sides by 0.2. Over here will become 1, and we'll be left with x equals, and go to my calculator, 5 divided by 0.2. And we'll get our answer of 25. All right, number 7. Make sure I give myself enough room to work it. So before I start, these fractions look a little bit different than some of the other fractions we've solved, and you probably already know, but I'm just going to point out that x over 3, because our coefficient of variables, when they don't have a number written, we always can imagine a 1 there. So I'm just going to show that we could also write this fraction like this. So I'm going to rewrite this equation. 1/3 x minus 3 equals 1 over 9 x plus 3. So again, we have these fractions here, and I'm going to go in and circle and box. So we're boxing variables and circling constants. Our goal now here is to identify, so these are our variables, and what we're looking for is our least coefficient. So initially you might think that 1/3 is smaller, but if you think about 1/3 and 1/9, if you had a piece of pie or a piece of pizza, would you rather, and you were really hungry, would you rather have 1/3 of the pizza or 1/9 of the pizza? So like sharing your pizza with 9 people or 3 people. So you'd get a lot more with the 3. So that means we know that our 1 over 9x is our smallest coefficient. So on the right, that becomes 0. And then we can go to our calculator and go 1/3 minus 1/9. So again, and 1 over 3 minus 1 over 9. And this calculator is a free app in the Apple App Store, and it functions almost identically to the yellow calculators that we have in school, so I would definitely recommend this. You type in graphing calculator in the App Store, and this will be the first one that you can choose from. So when you choose enter, so I got a decimal over here, so I'm going to have to turn that decimal to a fraction since it's a repeating decimal. So what you do, you push under alpha, it says math, and then this first one, convert to fraction. and then it'll take my answer and convert it to a fraction, push enter, and we have 2 over 9. So now we have 2 over 9x minus 3 equals 3. All right, now we are looking at our constant. So we have a negative 3 and a 3, both on different sides of the equal sign. So we're going to move our 3 because that was a negative and a positive. So now on the left we have 2 over 9x equals 3 plus 3, which is 6. And our last step is to ask ourselves if we have a coefficient other than 1. And in this case we do. Our coefficient is 2 over 9. So what we're going to do is multiply by our reciprocal. So the reciprocal of 2 over 9 is 9 over 2. I don't change any signs when I'm doing the reciprocal. I just flip the fraction. So I'm going to do that on both sides. And just to show you the multiplication, so where we'll end up with 1 on the left side, I'll do that in the calculator here. So alpha, so 2 over 9 times 9 over 2, because our goal is to get our coefficient to be 1. So you see over in that bottom right hand corner, we get a 1 there, and that was our goal. So we have a 1, or we don't have to write it, and then 6 times 9 over 2. 6 times 9 over 2, which again was our reciprocal of our coefficient. And then we get 27. X equals 27, which is the correct answer. We see that here, D. All right, going to this one. I'm going to, again, write it off to the side so that I can have place to work it down. So we have 4x minus 5 equals negative 2x plus 13. So again, I just rewrote it so that I could work it out this way. So I'm going to box and circle for my constants. And again, we don't have any like terms, so we're going to have to ask ourselves if we have variables on both sides, and we have a variable here and a variable here. So we're going to move our least coefficient. So the coefficient being the number before the variable. So we have a negative 2, which is smaller than 4. So we're going to add 2x to both sides. So it'll become 0 on the right side. And then we will simplify down. So we'll have 4x plus 2x, which is 6x minus 5 equals 13. And then we have our constant numbers, and remembering to include the sign before. So we're going to add 5 to both sides, since this 5 is on the same side as the variable, because we're trying to isolate that 6x. So that will give us 6x equals 18. And our last step is to ask ourselves if we have a coefficient other than 1, and in this case we have a 6. So we're going to divide both sides by our coefficient and be left with 18 divided by 6, which is 3. And we see that here as B. All right, this one was most commonly missed, so let's break it down. Mateo started with 20 pieces of gum and gave away X pieces. Josh started with 35 pieces of gum and gave away twice as many pieces as Mateo did. How many pieces of gum did Mateo give away if they had the same number of pieces? There's a typo there. Had the same number of pieces of gum left. Sorry about that. That was a mouthful. Okay, so I'm going to go back in and try and extract an equation from my word problem. So Mateo started, so that means we're having an initial start of 20 pieces, which is going to be our constant. And he gave away X pieces. So we don't know what that X pieces is, but we know he gave them away, so he's losing pieces from his 20. Josh started with 35 pieces and gave away twice as many as Mateo did. So again, remember, Mateo gave away X number of pieces. And we're looking for how many pieces of gum did Mateo give away for them to have the same number at the end. So we have Mateo, and so Mateo had 20 pieces and he gave away X number of them. And that's going to equal Josh, who had 35 to begin with, and he gave away 2 times as many, because Mateo gave away X, so Josh gave away 2X. And so going in and circling and boxing, circling constants, boxing variables. So from here, we don't have any like terms, but we do have variables on both sides of the equal sign. We have a variable here and a variable here. So we're going to move our least coefficient. So if you weren't looking at the negatives in front, you might think to move the x. But since we have a -2 is smaller than -1, so we're going to add 2x to both sides. So negative, and again, remembering that there's a 1 here. So -1 plus 2 is going to leave us with a positive 1x. So we have a 20 plus x equals 35. So then we're going to look at ask ourselves if we have constant numbers on both sides, and I just highlighted those in purple. So from there, we're going to move the constant that's on the same side of the variable, and since we 35 minus 20 is 15, and since our last question is to ask ourselves if there's a coefficient other than 1 with the variable, so right here, all we have is a 1, so we're good, done, x equals 15. So one of the most common mistakes I saw in this problem was right here as the thing I'm circling. A lot of people did -1 plus 2, and they ended at a 3x. And so a lot of people chose 5 as their answer because they did 15 divided by 3, but -1 plus 2 is just a 1. All right, number 10. Jerry has a new job and earns a salary of $45,000. Victoria has a new job and earns a salary of $54,000. Jerry will receive a salary increase of $2,500 per year, and Victoria will receive a salary increase of $1,500 per year. Which equation can be used to find x, the number of years it will take Jerry to earn the same salary as Victoria? All right, so lots of numbers. Let's break it down. So Jerry earns a salary of $45,000, and Victoria earns a salary of $54,000. All right, and then Jerry will receive a salary increase of $2,500 per year, and Victoria's looking at an increase of $1,500 per year. So I boxed them because it said per. So we're looking for the same. So let's look at Jerry and Victoria. Make sure we get our numbers on the right side. So Jerry has the $45,000 plus he's getting a salary increase of $22,500 per year, and Victoria is having a salary of $54,000, and she's increasing at $1,500 per year. So in this case, we're looking for the $2,500. So this first one, we see an X on here, and so that can't be right. Again, we're seeing these X's, so again, we could have used process of elimination right here and chosen C just based on the fact that those 4,500 should not have had X's on them. All right, Veronica is ordering trophies for her school. Company P charges $350 for each trophy and a one-time engraving fee of $25. Company R charges $750 for each trophy and a one-time engraving fee of $17. Which inequality can be used to find X, the minimum number of trophies that can be ordered so that the total charge of Company P is less than the total at Company R? Okay, let's break this down. So we have a $350 for each trophy. So that's going to be, each of them is going to increase, so that's a variable, and a one-time engraving fee of $25. I'm going to pause for a second and just write that down here. So we have Company P with $350X plus 25. I'm going to go on. I have Company R charges $750 for each trophy and a one-time engraving fee of $17. So then we have Company R, which is going to be $750X plus 17. So at the end, we're wanting Company P is less than the total at Company R. So reading from left to right, we want P to be less than R. So this is where we're ending right here. So you're going to want to find the one that looks like this, and it looks like this is our answer here, C. So these ones both say greater, and this one here, we have the variable on the wrong. We have the variable on the wrong number. All right. At a store, each notebook has a cost of X dollars. Which situation can be represented by this inequality? Okay, so notebooks are represented by X. So this is saying we have 5 notebooks. Is less than, because right here, is less than 3 notebooks. Again, we have our X. This right here is our notebooks. 3 notebooks plus something. We don't know what this 2 represents. This 2 is a constant, and it's going to be some type of charge. So we need to read through these and see which one matches closest to this. So A says the cost of 5 notebooks is greater than, we already know it's wrong. B says the cost of 5 notebooks is less than, okay, we're good, than the cost of 3 notebooks with a $2 off coupon. So $2 off coupon, we're still adding money. So right here, that can't be right. All right, the cost of 5 notebooks is less than the cost of 3 notebooks plus a $2 pen. Okay, that looks like it could be right. Let's read the last one. The cost of 5 notebooks is $2 greater than the price of 3 notebooks. And that just doesn't even make sense. So that's going to end us at C. All right, our last equation, stuck with me. Mr. Campbell had $330 in his savings account when Miss Walton opened a savings account with $0. Mr. Campbell deposited $30 into his account every week for X weeks. Miss Walton deposited $50 into her account every week for X weeks. Which inequality represents this situation when the amount of money in Mr. Campbell's account was greater than the amount of money in Miss Walton's account? So let's first go in and break this down. So Mr. Campbell had $330. And so I'm going to go, Mr. C had $330. So Mr. Campbell deposited $30 into his account every week. So deposit means add. He's adding $30 each week. Miss Walton has $0. And she's adding $50 per week. So we're looking for the inequality where Mr. Campbell is greater than Miss Walton. So Mr. Campbell needs to be greater than Miss Walton. So in our answer choices, we're saying the $30 was with Mr. Campbell, so that's already not right. So this is saying that Miss Walton's $50 per week is greater than, no, we don't want that. The C is saying $30, or Mr. Campbell's $30 is greater than, in C, Mr. Campbell, I guess, gave me my his $330, which is not right. And this one is saying Miss Walton's $50 per week is less than Mr. Campbell's. So this one could be a little confusing because just remembering that it can be written both ways as long as the sign itself is opening in the same direction. So that'll land us at D. And I hope that this helped. And thanks for watching.